This video will review how to factor trinomials with a leading coefficient of 1. And what that means is this is just a 1x squared. And a quick reminder that factoring is a technique that we use to rewrite things that are sums or differences, meaning things that involve addition and subtraction, and rewrite them as a product which involves multiplication. So in order to understand how to do that, we have to really understand how multiplying binomials works. So just a quick review here. If you want to multiply x plus 5 times x minus 7, we need to use the distributive property. So I have x squared for the first terms. The outside terms give me negative 7x. The inside terms give me 5x. And the last term gives me negative 35. And then these two terms here are like terms, so I can combine those and get x squared minus 2x minus 35. So one thing I want you to notice is that we went from two binomials. When we multiplied it out, we got 4 terms. And then when we combined our like terms, we got 3 terms, which is where the trinomial comes from. And I'm not sure if you've seen this before, but the other way to multiply binomials is to use an area model with rectangles. You take each factor and you put it as either the length or the width of a rectangle. So this is x plus 5, and the other side is x minus 7. And then I think of this as multiplying to get the area on the inside. So x times x gives me x squared. This 5 times x gives me 5x. Negative 7 times x is negative 7x, and 5 times negative 7 is negative 35. And if you look at the 4 terms that I have in here, those are the same as the 4 terms that I got in this second line. And if I do the same thing over here with these two binomials, I get x squared minus 3x, and then minus 8x plus 24. And then when I combine my like terms, I get x squared minus 11x plus 24. And I'll show you the area model one more time. I take one binomial and put it on one side, the other binomial and put it on the other side, and then I think of this as having 4 smaller rectangles inside that represent the 4 distributions. So x times x gives me x squared, negative 3 times x gives me negative 3x, negative 8 times x gives me negative 8x, and negative 3 times negative 8 gives me positive 24. And again, the 4 terms that I have inside the box are the same as the 4 terms that I have in this second line. Now the reason I wanted to show you it both ways is that there are patterns in the numbers that show up in the box, or the numbers that show up in the 4 terms, and the coefficients that show up at the end here. So one thing you might want to notice is that when I look at these two middle terms here compared to these outside terms here, which if you look in your rectangle, it's these terms compared to the other diagonal terms. One thing you want to notice is that these diagonal terms here, which are the middle terms there, they have a sum of negative 2. And the other thing that happens is that when you multiply across the diagonal in this box, which is the same as multiplying these two middle terms here and these outside end terms here, you get the same thing. Negative 35 times x squared is negative 35x squared, and negative 7x times 5x is negative 35x squared. And the same thing happens here. If I multiply on this diagonal, I get positive 24x squared. And the coefficient there is positive 24, which is right here, and they have a sum of negative 11. So let me write that down again. These two middle terms that I have here, which come from these spots here, add up to be this middle term, positive 5 and negative 7, add to be negative 2, and they multiply to be negative 35. Over here, these terms here that end up inside the parentheses, they multiply to give you positive 24, and they add up to be that middle term. And that's what we're going to need to figure out how to factor. So this says factor using the product and sum facts, that relationship that we just discovered. So what we just discovered is that the numbers that are going to end up in these parentheses here are going to have to be the numbers that give you a product of 8, positive 8, and they're going to have a sum of this middle term, which is positive 6. And those numbers that I come up with that have a product of 8 and a sum of 6, those are the numbers that will give me my 4 terms, which will lead me back to the parentheses. So I always start with the product, and I write down everything I can think of that multiplies together to give me 8. So it could be 1 times 8, could be 2 times 4, 3 doesn't divide into 8, and 4 times 2 I've already got in my list. So those are the only possibilities, and the ones that give me 6 as a sum are 2 and 4. So that means that the 4 terms that I had before it got condensed to be a trinomial are 2x and 4x, and then we know that these middle terms lead to the numbers in the parentheses. So you'll notice that here's the 2x and here's the 4x. So this is the factored form, x plus 2 times x plus 4. Let's take a look at another one. To do this one, I'm looking for two numbers that have a product of 30, positive 30, and a sum of negative 11. Now some of you might be able to recognize what those numbers are. If you can't, I recommend that you just start with the product fact and start writing down the pairs of numbers that multiply to give you 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't divide into 30, 5 times 6, and then I would come up with 6 times 5, which I've already got in my list. So those are all the possibilities. I want the sum to be negative, which means that I would need both of these things to be negative here. And the ones that give me a sum of negative 11 are the negative 5 and negative 6. So what that tells me is that the numbers that end up in these parentheses after I factor it are x minus 5 times x minus 6. And just to be clear, that also is how this would split into 4 terms as the intermediate step if I were kind of going in this direction and multiplying. Again, here's the negative 5x and here's the negative 6x. So this is my factored form in this one. And the last one I have for you here is x squared minus 13x minus 30. You got to be careful about the signs here. For this one, I want a product of negative 30 and a sum of negative 13. So the fact that I want a product of negative 30 means that I'm going to need one positive and one negative number. Which one's going to be positive or negative is going to depend on what I want this sum to be. So first I'm going to ignore that negative on that 30, and I'm just going to write my list again. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. That's my complete list. So it looks like I have a potential in a couple spots to get a 13 out of it. Might involve a 2 and a 15, might involve a 3 and a 10. Now, to get a negative 30 for a product, I need to have one positive and one negative. So if I look at, say, the 3 and the 10, and I keep the 3 positive and the 10 negative, then I don't get a sum of negative 13. If I make the 3 negative and the 10 positive, I still don't get a sum of 13. So it's not that one. It has to be the 2 and the 15. And to get a sum of negative 13, I'm going to have a positive 2 and a negative 15. So those are the numbers that will end up in these parentheses. I'll have an x plus 2 times an x minus 15. And again, if I wanted to fill in the intermediate step here with the 4 terms, I'd have x squared plus 2x minus 15x minus 30, and these two would combine back to give you that negative 13. So that's how you check. And so x plus 2 times x minus 15 is the factored form.